Welcome to the course on network theory. Today we shall solve the numericals on jet parameters by considering the given circuits. Before going to that, we shall see where we are trying to apply our jet parameters in real world. Okay. Until now, we have studied the concept of mathematical, but engineering becomes meaningful only when we try to see the real applications. First, the jet parameters are widely used in the audio amplifiers. Here, the audio amplifier circuit is considered as the linear circuit which we are unknown with. We have tried to take 4 terminals from out of it. And here we are having an input terminals and this is an output port. Okay, we are having an input port over here and we are having an output port over here, and we are trying to connect the input port to the mic and the output port to the speaker. So in order to have a capture the clean input, so first we need to have a input matching. So we need to have the Z11. So if this is physically matched the microphone's impedance, then it captures the clean audio, which is a distortion free. And if at output port, if the output impedance, that is Z22, is matches with this impedance of the speaker, then we will be able to deliver the maximum power without any reflection. Whereas if it is Z21, we try to compute the forward transfer impedance, because this indicates the actual amplification gain. It defines how loud we can transfer from signal from the input port to the output port. That is the reason we are trying to take Z21 rather than Z12. It is the ratio of V2 by I1. We are trying to have an input at the first port and trying to see the response at the output port. Now let us see the other applications. The other application can be found in the power system model. So in large power network, we are having a transmission grid. We often try to analyze the voltage and current behavior between in 2 buses, or that we say that 2 substations. Instead of analyzing the entire network every time, engineers try to represent the sections of the grid using the equivalent 2-port models. So, and by doing this, it will help in studying the voltage regulation, how the power flow is power flow behavior across the network, what the fault analysis will be able to do the stability studies easily. So jet parameters tries to simplify the large power system calculations. Next, the another important application is the microwave engineering. At high frequencies, conventional circuit analysis becomes very difficult because transmission line affects the dominant, distribution parameter becomes significant, and wave behavior must be considered. So in such cases, 2-port parameter models helps engineering try to design the RF amplifier, radio frequency amplifier, microwave filters, matching networks, antenna field systems. Right? Another major application is the integrated circuit design. Inside IC chips, we are going to have thousands or millions of components which are interconnected. So design engineers cannot analyze each transistor individually at system level. So what they try to do, sub-circuits using our 2-port network parameter representation. So this helps in the signal integrity analysis, gain calculations, noise modeling, frequency response evolutions. And jet parameters also are used in the network synthesis. So here is the process of designing the circuits to meet the desired specific applications. For example, designing a filter with specific frequency response, designing impedance matching circuits. So parameter models help in systematically constructing such kind of networks. Finally, these are also used in control systems. In many control applications, electrical subsystems interact with mechanical or thermal systems. So using this parameter model helps in creating simplified mathematical representation for stability analysis, feedback design, system modeling. So overall, jet parameters are not just theoretical tools, they are foundation for various engineering tools used across multiple domains. So Z parameters are widely used in power systems, microengineering, integrated circuit design, network synthesis, filter construction, control system modeling. So this Z parameters tries to help the engineer simplify the complex system into a manageable mathematical forms. So with the introduction and the applications of Z parameter, now let us consider some numerical problems. Now we shall solve for Z parameter for a given circuit using various methods. In the first method, we will be trying to use a mesh analysis, that is making use of KVL and Ohm's law. So here in the first numerical, what we need to do? We need to compute the Z parameters for a given circuit, and we need to make an observation whether the network is a reciprocal or symmetrical or both. So let us take this particular circuit. So if you observe this circuit, we are having three meshes. So as a result, we are going to have assigned three mesh currents. So let us assume this is mesh current 1, let it be I1. So we are trying to assign the direction of the mesh current as per the current I1, and let it be this is I2 going in a anti-clockwise direction. Now we need to write mesh equations. We know that the voltage across a particular loop should be equal to 0. So it is V1 is equal to the voltage rise should be equal to voltage drop. So what is the voltage drop across this? It is R1 into what is the current flowing through it? It is I1 is coming from top to bottom and I3 is coming from bottom to top. So it is I1 minus I3. So we can write V1 equal to I1 R1 minus I3 R1. This is our first equation. Now for the second equation, we can write V2 equal to R3 into I2 plus I3. So we can write it as I2 R3 plus I3 R3. So this is our second equation. And we can write the third mesh equation. We don't have any voltage rise. We are having only the voltage drops. So what can we write? It is minus I1 R1 plus I2 R3 plus R1 plus R2 plus R3 into I3 equal to 0. This is our third equation. But what we need to compute? We need to compute the Z parameters. So how my Z parameter equations looks like? V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. So if you observe carefully, we are having four parameters: V1, V2, I1, I2, and four network Z parameters, that is Z11, Z12, Z21, Z22, which we need to compute. So if you observe these two equations, we have only V1, V2, I1, I2. So we don't have any I3 term here. So our objective here is to eliminate this I3. How could we write I3 equal, right? So we can write I3 equal to I1 R1 plus I2 R3 divided by R1 plus R2 plus R3. Now we should substitute this I3 in first and second equations. So if we try to substitute in this particular equations I3 in first and second, what we are going to see? Let us write here V1 equal to R1 I1. Why we are trying to substitute? Because we are trying to eliminate this I3 term. So minus R1 into R1 by R1 plus R2 plus R3 into I1 minus R3 by R1 plus R2 plus R3 into I2. So if you observe here, we are getting I1 and I2. So let us take I1 common. So my V1 is equal to R1 minus r1 square divided by r1 plus r2 plus r3 into I1. Here minus into minus, we are going to have plus r1 r3 divided by r1 plus r2 plus r3 into I2. So if you try to rearrange these equations, we are going to get v1 equal to r1 r2 plus r1 r3 divided by r1 plus r2 plus r3 into I1 plus r1 r3 divided by r1 plus r2 plus r3 into I2. So if you observe carefully, we are having plus r1 into r1 square, and we are having minus r1 square. We have eliminated it and we have done directly. So if you compare this equation with our main equations here, so we will be able to identify that my z11 is equal to this term. So this will be my z11, which is equal to r1 r2 plus r1 r3 divided by r1 plus r2 plus r3, and this will be my z12. So z12 equal to r1 r3 by r1 plus r2 plus r3. Okay. Now if you try to substitute this I3 in this equation, let us see what is going to happen. So my V2 will be equal to R3 I2 plus R3 into R1 by R1 plus R2 plus R3 into I1 minus R3 divided by R1 plus R2 plus R3 into I2. So if you try to rearrange this equation, you are going to get R1 R3 divided by R1 plus R2 plus R3 into I1 minus R3 square okay, let us first write a comma plus, so if you try to write R3 minus R3 by R1 plus R2 plus R3 into I2. So if you try to rearrange this equation further, we are going to get V2 equal to R1 R3 divided by R1 plus R2 plus R3 I1 plus this, we are going to have R3 into R3 minus this one. So we are going to have cancelled each other. So it is R1 R3 plus R3 R2 divided by R1 plus R2 plus R3 into I2. So if we compare with the actual Z parameter second equation, we can see that this will be our Z21, that is Z21 equal to R1 R3 by R1 plus R2 plus R3, whereas this will be my Z22. So Z22 equal to R1 R3 plus R2 R3 divided by R1 plus R2 plus R3. So this is written over here. So if you observe here, my this Z12 and Z21, you can see both are equal. It is R1 R3 by R1 plus R2 by R3. So we can say that the given circuit is a reciprocal circuit. Whereas if you see here, we are having R1 R3 here, we are having R1 R3, and we are having here R1 R2, but here we are having R2 R3. So my Z11 is not equal to Z22. So it's not a symmetric. And we have observed that Z12 equal to Z21. So it is a reciprocal. So our given circuit is a reciprocal circuit, and this is not symmetrical. Not symmetrical circuit. Okay. So in compact form, we can write our Z parameters in this particular way. So we have said that our network is a reciprocal circuit but not a symmetrical circuit. Now let us solve the same numerical using method 2. That is, we are again computing the Z parameters for the same circuit and we are identifying whether the circuit is a reciprocal or not. However, rather than using our mesh analysis now, we try to make use of another network reduction technique. That is, by making use of our star to delta conversion. So, if you observe here, we are having this particular mesh in a delta fashion. So, we are trying to convert this into a star. So, how do we connect? So, our resultant circuit will be something like this. So, we are going to have a resistor over here and we are going to have another resistor connected to this particular node, and we have another circuit, another resistor connected over this particular node. So, let us assume this is RA, this is RB and this is RC. So, my RA can be written as R1 R2 divided by R1 plus R2 plus R3, whereas my RB is R2 R3 divided by R1 plus R2 plus R3, and my RC is nothing but R1 R3 divided by R1 plus R2 plus R3. So, after computing this, we are trying to convert the given circuit in this particular way. So, this is our star network. And this is our RA, and this is RB, and this is our RC. So, this is our V1 terminal, voltage applied across this terminal, and this is my I1, and this is V2, and this is my I2. So, plus minus. Now, let us apply our mesh analysis. So, this is I1 and this is our I2. So, we can write our equation as V1 equal to RA plus RC into I1 plus RC into I2, whereas V2 can be written as RB plus RC into I1 into I2 plus RC into I1. So, if you try to substitute our RA, RB, this RA, RB and RC in these equations 1 and 2, we are going to get my V1 is equal to R1 R2 plus R1 R3 divided by R1 plus R2 plus R3 into I1 plus RC, that is R1 R3 by R1 plus R2 plus R3 into I2. Now, if you try to substitute RB RC in this particular second equation, we get V2 equal to RB plus RC means it is R1 R3 plus R2 R3 divided by R1 plus R2 plus R3 into I2 plus RC term, it is R1 R3 divided by R1 plus R2 plus R3 into I1. So, if you observe, this is our Z12 and this is our Z21 and this is Z11 and this is our Z22. This is our Z22 and this is our Z11. So, if you observe the results from the previous slide, so we can see that both are equal. So, depending upon the circuit we have, we need to reduce the circuit so as that we can compute the Z parameters very easily. So, it is not always a hard and fast rule that we need to only apply our mesh analysis. So, we can use our network reduction techniques wherever possible, and we can apply our mesh analysis to compute this particular Z parameter very fast. Now, let us see how do we compute Z parameters in other way, the third method. Now, we shall solve Z parameters for the same circuit using the method 3. So this is the same circuit which we have considered previously, but we are trying to solve the numerical by different method. What kind of method we are trying to use? We try to use the conventional way of finding the Z parameters. That is, we are going to have two cases. In the first case, we are trying to open the second port. That is, we are trying to make I2 equal to 0. And here, when I2 equal to 0, we are trying to find our Z11 and Z21 parameters. In case 2, we try to open the first port. That is, we try to make I1 equal to 0 so that we could compute Z12 and Z22. Right? So we try to make use of the conventional way of finding the Z parameters here in method 3. So let us take the case 1. Now we are trying to make the second port open. So we are trying to make I2 equal to 0. Now how many circuits looks like? We are going to have a circuit in this particular way. This is our R1 and we are having R2 and we are having R3, but there is no mesh current, so I am trying to remove this particular thing, but we are going to have voltage across this particular two nodes is V2, and let us assume this is I1 and the current flowing through this is I3, and we have applied V1 across here. Now let us write the mesh equations. So if we try to write mesh equation for the first mesh, so we are going to get V1 equal to, here V1 is the voltage, right? So V1 equal to I1 R1 minus I3 R1. This is our first equation. Now we shall write the second mesh equation. We don't have any voltage, right? So it is 0. It is minus I1 R1 plus R1 plus R2 plus R3 into I3. This is our second equation. So if you observe, we have I2 equal to 0. So my equations of Z11 is equal to V1 by I1 when my I2 equal to 0. So the objective is to find the ratio of V1 and I1 for the first one. Next is Z21. So it is V2 by I1 when my I2 equal to 0. So we need to find V2 over for the second one. So now let us do that. So if you observe, we don't have I3 term, so we shall eliminate I3 first. So if you try to rearrange this equation 2, we can write our I3 as I3 equal to I1 R1 divided by R1 plus R2 plus R3. Now if you try to substitute this third in 1, put 3 in 1, we get V1 equal to I1 R1 minus R1 into, what about I3? It is I1 by R1 divided by R1 plus R2 plus R3. So trying to take I1 as common, so we are going to have R1 square plus R1 R2 plus R1 R3 minus R1 square divided by R1 plus R2 plus R3 into I1. So if you try to take the ratio, we are going to get V1 by V1 equal to R1 R2 plus R1 R3 divided by R1 plus R2 plus R3. So this is the same one which we got previously. You can see here my R1 R2 plus R1 R3 by R1 plus R2 plus R3. So R1 R2 plus R1 R3 divided by R1 plus R2 plus R3. Now we shall solve for Z21. How you are going to get the Z21? Now let us solve for second one. So how can we get? We know that V2 equal to I3 into R3, right, and I3 into R3. So let us substitute over here. So my Z21 is equal to V2 divided by I1, but what is V2? It is I3 R3 divided by I1. Now we shall eliminate this I3. What is I3 here? I3 equal to I1 R1. It is I1 R1 divided by R1 plus R2 plus R3 into R3 divided by I1. So my I1 get cancelled. So we get R1 R3 divided by R1 plus R2 plus R3. So this is the same value which we got over here, R1 R3 divided by R1 plus R2 plus R3. So in this way we are trying to find the values of Z11 and Z21. Now let us take the case 2. So in case 2, what we are trying to make? I1 equal to 0. So in this case, let us assume this is I2. Now applying the mesh analysis equation here, it is V2 equal to, we are getting I2 R3 plus I3 R3. First one. The next one, we don't have any voltage rise, so it is 0 equal to I2 R3 plus R1 plus R2 plus R3 into I3. So this is our second equation. So similarly, we need V2 by I2, so we need to eliminate I3. So we are trying to take I3 from here. So my I3 is equal to I2 R3 divided by R1 plus R2 plus R3. Let us assume this is third equation. Substituting in the first equation, we get V2 equal to I2 R3 plus minus I2 R3 divided by R1 plus R2 plus R3 into I2. So if we try to rearrange, we get V2 by I2 is equal to R2 R3 plus R1 R3 divided by R1 plus R2 plus R3. So this is the same term we have got for previous method, where V2 by I2 is nothing but this is Z22. Now we shall find for Z21. So my Z21 can be written as V2 by, we shall find Z12. So Z21 is for case 1, Z12 is for case 2. So it is V1 by I2. V1 by I2. So we are having input put as 0. So it is V1 by I2. But what is our V1? V1 is nothing but voltage across this particular resistor, that is minus R1 into I3 divided by I2. Now let us substitute I3 over here. What we are going to get? Minus R1 into minus I2 R3 divided by R1 plus R2 plus R3 divided by I2. So my I2 get cancelled. So we get R1 R3 divided by R1 plus R2 plus R3. So these are the same parameters which we got in the previous methods. So in this way, we can apply the Z parameters using our third method. Now let us solve the same numerical using a method 4. In method 4, we try to make use of our nodal analysis. So our first objective here is to find how many nodes do we have for the given circuit. So you can observe that we have totally 3 nodes, and 2 are non-reference nodes and 1 is reference node. So here is the reference node, which we assume that it's a 0 volts. Now we try to apply our nodal analysis at this particular 2 nodes. Okay, so if you assume this is V1 and if you assume this is V2, to be precise, as there is no drop over here, the voltage at this particular node will be equal to the voltage across this particular node, and voltage across this at this particular node is equal to the voltage at this particular node. Okay, so now applying nodal analysis at node 1. So at node 1, so what is the incoming current? The incoming current is I1, and what is the outgoing current? It is V1 minus V2 by R2 plus V1 by R1. Here we assume that the voltage at node 1 V1 is greater than voltage at node 2, that is V2. Now try to rearrange this particular equation. I1 equal to 1 by R1 plus 1 by R2 into V1 minus 1 by R2 into V2. Similarly, try to write at node 2. So at node 2, the incoming current is I2, and what is the outgoing current? It is V2 minus V1 by R2 plus V2 by R3. Now try to rearrange these particular equations. So we get I2 equal to minus 1 by R2 into V1 plus 1 by R2 plus 1 by R3 into V2. So this is our first equation and this is our second equation. But these equations are in the form of I1 in the function of V1 and V2, and I2 is a function of V1 and V2. But what we require? We require V1 is a function of I1 and I2, and V2 is also a function of I1 and I2. So we require in this particular way. So in equation 1, V2 is extra and I2 is absence. And in second equation, V1 is extra and I1 is absent. So we try to rearrange these equations. Now what we try to do, we shall eliminate V2 from first equation, for which we try to make use of equation 2. So how do we write this V2 equation? So it is V2 is equal to R2 R3 divided by R2 plus R3 into I2 plus 1 by R2 into V1. Right? Now try to substitute this V2 over this particular equation. So what we are going to get? So what are we going to get? That I1 is equal to R1 plus R2 divided by R1 R2 into V1 minus we are trying to substitute V2 in equation 1. And if you observe here, we are having in V2 as R2 into R3, and we have a denominator R2. So I am trying to cancel it out. So we are going to have R3 by R2 plus R3 into I2 plus 1 by R2 into V1. Now we have V1 over here and we have V1 over here, and we shall send I2 to the left hand side. So what we are going to get? I1 plus R3 divided by R2 plus R3 into I2, which is equal to R1 plus R2 divided by R1 R2 minus R3 divided by R2 into R2 plus R3 into V1. So we shall simplify this particular part now. So if you try to simplify that, we are going to get say I1 plus what we have R3 by R2 plus R3 into I2. Now we are trying to simplify it. R1 plus R2 into R2 into R2 plus R3 divided by R1 R2. R2 into R2, we are going to get R2 square into R2 plus R3, and we have minus here, that is R1 R2 R3. So completely we are going to have this is as V1. So if you try to compare, we are having here what we have done, R1 R2 multiplied with R2 plus R3, and we have minus R1, R2 and R3 here. So we have written over here in this way. Now try to see that R2 is common here and try to eliminate this R2. So we are going to have R2 eliminated over here, and we can rearrange this equation here. R2 plus R3 into I1 plus R3 divided by R2 plus R3 into I2. Why we are trying to do? We are trying to eliminate this R2 plus R3 here. Okay. So which is equal to R1 plus R2 into R2 plus R3 minus R1 R3 divided by R1 into R2 plus R3 into totally we are multiplying with V1. So this R2 plus R3, this R2 plus R3 get cancelled, and we are trying to send this particular numerator towards the left hand side. So what we are going to get? Or let us rearrange this equation first. So if you try to rearrange, we are going to get R1 R2 plus R1 R3 plus R2 square plus R2 R3 minus R1 R3 divided by R1 R2. So this R1 R3 get cancelled. So what we are going to have here? R1 R2 plus R2 square plus R2 R3 divided by R1 R2. Now if you observe here, we are having R2 as common, so we are trying to take it as common. So R1 plus R2 plus R3 divided by R1 into V1. Now we are trying to send this to left hand side. So what we are going to happen? So my V1 will be equal to R1 into R2 plus R3 divided by R1 plus R2 plus R3 I1 plus R plus, and we have R3 divided by R1 R3 divided by R1 plus R2 plus R3 into I2. So this becomes my Z11, and this particular term becomes my Z12. So my Z11 is equal to R1 into R2 plus R3 divided by R1 plus R2 plus R3, and we have a Z12 equal to R1 R3 divided by R1 plus R2 plus R3. So this is how we got even equation in terms of I1 and I2. So if you try to see in the previous numerical answer, we got the same R1 into R2 plus R3 divided by R1 plus R2 plus R3, and Z12 as R1 R3 divided by R1 plus R2 plus R3. So now what we need to do? We need to find Z21 and Z22. So for which let us assume this equation number is 3. Now try to substitute the third equation in the second equation which we have over here. Okay. Now let us substitute over that. So what we are going to get? Actually, what is the equation we have? We have V2 is equal to R2 R3 divided by R2 plus R3 into I2 plus R3 divided by R2 plus R3 into V1. So we are trying to eliminate this particular V1. So by substituting that one. So my V2 is equal to R2 R3 divided by R2 plus R3 into I2 plus R3 divided by R2 plus R3 into multiplying it R1 R2 plus R3 divided by R1 plus R2 plus R3 into I1 plus R1 R3 divided by R1 plus R2 plus R3 into I2. Now we shall take this I2 common, okay, and we shall take this I1 outside. So let us see what we are going to get. Okay, we can observe here this R2 plus R3 get cancelled. and we are going to have this R1 R3 divided by R1 plus R2 plus R3 into I1. So my V2 is equal to R1 R3 divided by R1 plus R2 plus R3 into I1 plus, let us take this I2 as common. So what we are going to get? R2 R3 divided by R2 plus R3 plus R1 R3 square divided by R2 plus R3 into R1 plus R2 plus R3. This completely multiplied with I2. So if you observe here, we got the equation V2 in terms of I1 and I2. And this is the value for our Z21, which is similar to their previous one. And this is also equal to Z12. And now we shall rearrange the particular terms over here. Now try to take this R2 plus R3 as common. We have R2 plus R3 over here and we have R2 plus R3 over here. We should take this as common. So my V2 is equal to R1 R3 divided by R1 plus R2 plus R3 into I1 plus R2 R3 plus R1 R3 square divided by R1 plus R2 plus R3 into I2 by R2 plus R3. Now we shall simplify these particular terms. What we are going to get? It is R1 R3 divided by R1 plus R2 plus R3 into I1 plus, try to multiply this one. What we are going to see? Say it is R1 R2 R3 plus R2 square R3 plus R2 R3 square plus R1 R3 square divided by R1 plus R2 plus R3 into this completely multiplied with I2 divided by R2 plus R3. Right? Now if you observe here, we have R3 is common in every term. So now let us take that as common. So my V2 is equal to R1 R3 divided by R1 plus R2 plus R3 into I1 plus, I am trying to take R3 common. So what we have? R1 R2 plus R2 square plus R2 R3 plus R1 R3 divided by R1 plus R2 plus R3 into I2 divided by R2 plus R3. Now try to see here, we can take R2 common from these two terms and we can take R3 common from these particular two terms. So if we try to take common here R1 R3 divided by R1 plus R2 plus R3 into I1 plus R3 into R1 plus R2 into R2 plus R1 plus R2 into R3 divided by R1 plus R2 plus R3 multiplied by I2 divided by R2 plus R3. So if you observe here, we are having R1 plus R2 and we are having R1 plus R2 here. Try to take common again. So R1 R3 divided by R1 plus R2 plus R3 into I1 plus, you are taking R1 plus R2 common. So R1 plus R2. So we are going to have it here R2 plus R3 divided by R1 plus R2 plus R3 into I2 by R2 plus R3. So this R2 plus R3 get cancelled. So we are going to have V2 is equal to R1 R3 divided by R1 plus R2 plus R3 into I1 plus R3 into R1 plus R2 divided by R1 plus R2 plus R3 into A2. So as I said, this will be my Z21 and this will be my Z22. So if you try to compare, you are going to get the resultant answer in this particular way. So whatever the method you follow, we are going to get the final answer the same. So what here in general we have done that we got the Y parameters and converted into Z parameters. With this, we are going to stop the computation of the Z parameters for a given circuit. So in the next lecture, we shall see the Y parameters. Thank you.